Welcome, Hornets, and thank you all for joining me today. This is going to be a video on the roots test. As you can see here, we're going to start with the roots test. And you'll notice I have the basic rules here. So if we're given a series A sub n and we want to know whether it converges, then when we have these A sub n's that have powers of n's, we need to use the roots test to get rid of that power of n so that we can take a look at it from that point. Furthermore, we're also trying to make sure that we can identify that root of n of that a sub n is going to be less than 1 for convergence, greater than 1 is going to be divergent. That includes infinity. Also, just a reminder, the convergence will also be less than 1 would include 0. So please keep those two in mind. Finally, we have to use a different test if we get a 1. So I've taken the liberty of writing a couple of problems down that I'd like you to look at. You'll notice that this one right here has that power, and that power is the problem that we have to deal with. So what we have to do is we're going to take the limit as n approaches infinity, and what we're going to do is we're now going to take the nth root of the absolute value of the n over 500, and this was to the nth power. Now these n's are going to cancel, leaving me with the limit as n approaches infinity, and I now have the absolute value of n over 500. And when I do this, we can clearly see that it's going to be infinity. And because I'm getting infinity, I know that I have a divergent series by the roots test. So let's just write that down. Therefore, divergent by the roots test. Okay, let's try another one. Let's take a look at, now keep in mind here, we can tell that as n approaches infinity, we have n to the nth. This is failing our nth term test. So let's just be clear on that. N to the nth over 500 to the nth is by Feppel diverging. So it does fail the nth term test. Please be aware of that. All right? And that would have been the first test that we do anyway. All righty. Here's the next question. Now you'll notice this has n to the nth, this has n to the 2nth. This now will pass the nth term test, and we can see that provided that we look at it as a whole. Okay, let's go ahead and take a look. If I have my limit as n approaches infinity, and I take the nth root of the absolute value of this 1 over n minus 1 over n squared, the quantity to the nth power, close my absolute value. The n's are going to cancel. I'm now looking at the limit as n approaches infinity, and I have 1 over n minus 1 over n squared, and we know that this will now converge. Okay, notice that the limit as n approaches infinity is 0, and 0 is definitely less than 1, and therefore this series converges by the roots test. Alrighty, let's go ahead and continue. Let's see one more, and then we'll go ahead and end. Here's my last one. Now, here we have a situation where the natural log of n to the nth is slower than n to the nth by Feppel, so this does satisfy the nth term test, and I immediately go to the limit as n approaches infinity for the nth root absolute value of our a sub n, so I have ln of n over n, the quantity to the nth. The n powers are going to reduce. I'm now looking at the limit as n approaches infinity, and I have the natural log of n over n. Now, we know that as we do our limit by Feppel, this is going to 0 for my limit as n approaches infinity, which is less than 1. And therefore, we can say that this series converges, and it is converging by the roots test. And this is 3 examples to help you work through the roots test on your own. I hope this helps. Thank you very much. In the next installment, we'll be taking a look at the ratio test, and then we'll be taking a look at finding intervals of convergence as well as radius of convergence, assuming I haven't already done that. Thank you very much. Please be well and take care, and please be kind to each other. Thank you, and goodbye.